All right, so please make sure that you are looking at Form A for this one. What I want to do is go through and kind of talk the thinking through and hopefully um, be able to clear up some of the questions you might still have. So for number 1 and 2, where it says write an equation of a line, you have three things that you need to know to be able to write an equation of a line. There's the slope, which if you remember, it's the rise over the run. Or some of you will remember that you subtract the y's or subtract the x's. The other thing for equations of a line, if you know, I'm sorry, that's wrong. If you know both the slope and the intercept, you can plug in the slope and the intercept. Or if you don't know the slope and intercept, but you know the slope and a point, we have this formula. So the intercept's a little tricky to find, but I can easily find the slope. From this point to this point, if I look at the y's, because that's the rise, it looks like it goes up 15 and over 5, so the slope would be 3 over 1. I don't know the b, so I'm going to plug in y minus, and you can pick either point. 15 equals 3 times x minus 1. Get y by itself. First I'm going to distribute. That was minus, so add 15. And there's the final equation of the line. This question, what does the slope mean? Well, since this is inches and this is months, a child grows 3 inches per month. On this, on number 2, I recognize this as a constant equation, and all functions that are constant have this formula where the number is, what does it stay constant at? It looks like 3, so this is simply f of x equals 3. That's the equation. It has an equal sign. What does the slope mean? 3 over 1 would mean that it stays 3 miles per hour. Number 4 is extra credit. I'm going to do number 3 by elimination. I see that if the y were 3y, the y's would cancel. So I can go ahead and multiply everything by 3. So I'd have 9x minus 3y equals 21. And I'm going to keep this one the same. These are going to eliminate when I add them. 9x plus 2x is 11x equals 22. So my x value must be 2. Then I can go and plug into any one of these equations. I'll just take this 2 times 2 plus 3y equals 1. I need to figure out what y is. I'll subtract 4. 3y equals a negative 3. So y equals negative 1. And the solution is best written as an ordered pair. All right, the transformation of this linear function, you can think of lines as transformations, or you should know mx plus b. And so we should be able to figure out our slope and our y-intercept. Well, which of these has a y-intercept of positive 5? This looks like it's at a negative 5. This looks like it's at a positive 5. And this looks like it's at 4. So that will leave this as B. Number 6 looks like that must be A. And number 7 then would be left for C. Oh, that can't be right. Yes, for C. Double checking their slope. B is a negative slope, A is a positive slope. B is a negative, or C is a negative slope, so it should work. Let's take a look at the next page. It says graph the function and its parent function, then describe the transformation. On number 8, I recognize that the absolute value marks, and I know that you know absolute value marks have the is a v. So here's the parent function, 0, 0, and it's up 1 over 1 for slope. So perfect diagonal, and this would be f of x is the parent function absolute value of x. Now when I look at this equation, it looks like there's something being added outside of the brackets. And we talked about that in the general form. Something being added outside the brackets is your k, and this moves your transformation up and down. So it looks like the parent function is going to stay the same shape, but move up 2 units. There's 2 units, perfectly diagonal. So I graph the function, describe the transformation. It's a translation. I don't even mind if you use slide of 2 units up. Number 9, the parent function is the quadratic. F of x equals x squared. The parent function is at 0, 0, goes up 1 over 1, and that goes up 2 over 4 because it gets steeper since it's quadratic. There's the parent function. When we look at a generic quadratic, a times x minus h squared plus k. What's different between this and the original? There's a negative 1/3 being times. That's the a. It's being smushed up, multiplied by it. If a is a negative 1/3, that means that it must have been reflected because it's negative. So it's a reflection. And a 1/3 stretch. So it's going to, vertex will stay the same, but it gets a little wider. It's going to go up 1 over 3, up 1 over 3. Sorry, my marker's getting off. And it's upside down. This is where we're going with chapter 2. So this is just an introduction. And then finally, when we do this, I'm going to press pause and enter that in Desmos. Alright, so I've entered that. Notice you can't see my graph, so it was the wrench function that allows you to change your x's and your y's, what you can see. So my x's go from 0, so I'm going to change that to 0 to, let's just say 100 for my x's. And my y's, let's do 0 to, I don't know, I like it to go past it, so I'm going to go to 20. And there we can see our line. Here's our M, here's our B, and here's our correlation coefficient. Oops, not that one. Correlation coefficient. So it should be y equals M, which is negative 1/10 x plus 18. And if we go back, what type of function is that? And this, you can transfer this here. So this is your graph. If you count by 2's, I think that'll fit. 2, 4, 6, 8, 10, 12, 14, 16, 18. So it should have been something like that. The type of function is linear. I've done the estimation. All right, let's go to the next one. hopefully you recognize that this is the absolute value function that's been reflected. So here's the absolute value parent function. And the only thing that's really done is to multiply this by -1, so it flips. So you could have just a negative, absolute value, put the 1. The domain is your x's. All reals were used. And the range are your y's. So if you take a look at the y's, none of these are part of the graph. It's only from here down. So that would be all the y's that are less than or equal to 0. Number 12, here's the parent function. It's a quadratic because it's a parabola. It looks like it's been split up 4 units. Looks to be about the same width. We don't really have it to compare, so I'm going to assume it is. Remember to move it up or down. It's changing the k. Adding something, whoops, sorry, that's there. Adding something that's already on the outside. That's the equation, x squared plus 4. The domain again, eventually that's going to get wide enough to use all the x's. So all reals. But the only y's that are going to be used are from here up. So it would be all the y's that are greater than or equal to 4. And then number 13. Let the graph of g of x be a vertical stretch by the factor 2 and a translation of 2 units down. Stretches change the a, up and down changes the k. So I'm going to take f of x. The general form is a times x minus h squared plus k. However, the a is a vertical stretch by 2. So my new g of x then is going to be 2. There's no h, it's not moving left or right, so I'm just going to keep it x squared. And it's moving 2 units down on the outside, then that would be minus 2. And that's all we got. Please make sure that you have all of these fixed on your test. And then before you hand it in, you need to fill out the graphic organizer that I handed out to you.